Okay, everybody, in this video, I'm going to show you how to create a piece of Python code in order to create a 2D graph by accessing colab.research.google.com while logged into your DCU email account. When we access that URL, we're presented with a screen something like this, and we can create a new notebook or open one that we had already created before. On this occasion, I'm going to create a new notebook by clicking on New Notebook. When I do that, it opens up a screen like that which you are watching right now with a generic untitled name, and I'm going to give our new program a name PS154-2D graph. We've already decided that we're going to create a 2D graph, and therefore I'm giving it a name that's somewhat meaningful. I also want to give it a title, so I'm going to call it PS154 2D graph. And I'd probably like to make that bold. And I'm going to move that up to the top of the screen. So I've given our new program a name, and I've created a piece of text in bold to describe the function of the program that we are about to create. I'm going to create a piece of code. That section was already there. However, if it wasn't, I could just click on code. So I'm going to go about creating our first Python program using Colab. Okay, so one of the first things that you will see when you create a Python program is that you will import modules. In this case, we are importing the NumPy module because it contains many mathematical functions for use within Py, or numerical functions for use within Py, and we're giving it an alias of NP. So we will refer to functions from the NumPy module with the alias NP later on in the program, and you will see that. Since we're creating a graph, we want to import a module that has functionality or number of functions that make creating a graph easy in Python. And the function, or the module that we wish to import is matplotlib. .pyplot. We'll also give that an alias. So we're going to import matplotlib.pyplot as PLT. So when we refer to this module, in order to access one of the functions that it contains, we will use the alias PLT. Since we are going to create a graph, we're going to set up the parameters of the graph. So we are using the arange function from NumPy, which we are referring to as a np.arange, and we are using a number of arguments that the syntax of that function require. And just so that we can be clear about what we're doing, we're going to put in a comment, because comments are always useful to describe the pieces of code that we are creating. So we are defining that our x-axis in the graph that we're about to create will start at 0.0, will finish at 0.5, and will have a step size of 0.02. And if we wanted to ascertain what the other possible arguments or syntax variations on the np.arange function were, we could check out a manual page for np.arange. I just take it as read that this is a correct implementation of np.arange for what we want to do at the moment. We've already decided that we have a mathematical formula that we want to implement. And so I'm going to enter that formula now. We'll cut and paste because this is one that I've created before. So in the interest of speed, I will do a number of cut and paste from this point onwards. So this is the function, mathematical function that we want to implement. And in Python code, that function is represented by the code that I've just inserted. So one of the things that we want this program to do is create a graph with perhaps a number of mathematical functions represented graphically. Since we're going to be plotting, I'm going to enter a piece of code to plot. So plt.plot is using the plot function from matplotlib.pyplot. We're attempting to plot the value for y1, which has been calculated in this formula, on the new graph. At this point, we can execute the code that we have here just to see what happens. So let's just execute this piece of code. Okay, you'll have seen that the symbol for play, when we click play, showed that it was implementing some form of a calculation. And this is what has resulted from the calculation that we created. So we have one function for y1, and we have one line to plot the value of the graph of values for y1. I'm going to add two more calculations for y1, y2 and y3, for y I should say, y2 and y3. I'm also going to add the commands to plot those. Once again, we can click on the run symbol, and we can see that those calculations are represented in the new plot. Okay, we can see that we are, I suppose, incrementally developing a graph or a plot for the mathematical function that we've included. Perhaps we can do a little bit better. We can add annotations for the X and Y axis, and we can give it a plot title. So let's think about doing that. Okay, so let's consider including a legend. So I know that plt dot is the function from matplotlib to include a legend. So let's put it in its default position and run and see what happens. And you can see once again that we're incrementally getting to a graph with annotated details. Now let's think about adding the annotations for the X and Y axis. And we can click run again. And so we can see that we have position and time on the X and Y axis. So according to what we have entered in the code cell, we have run the commands and changed the graph. So once again, we're incrementally developing the graph towards where we want it to be. I'm going to add more items now. I'm going to add a title. So my guess from looking at plt.legend is that if we typed plt dot, we could probably give it a title. So we will call it to the graph. Let's see what happens. So we click on run and we get a problem. It says that syntax error, invalid syntax. Okay, it is clear that the syntax that I've used for plt.title is incorrect. So I'm going to do a Google search for syntax for matplotlib.pyplot.title. And this is the result. So I'm going to scroll down to where I see plt.title linear graph. Okay, so it would appear that I've left out the quotation mark. So let's go back to our graph, change syntax of the command, click run again. Okay, so we've got 2D graph included as the plot title. And so once again, it's improved upon where we were before. Okay, at this point, we may want to do something with the graph other than just display it on the screen. We might want to save it in a manner that we can use. We could perhaps create a JPEG or a PDF. Let's, on this occasion, try creating a PDF. So the command to use to do that is plot.savefig vibrations.pdf. And that will save a file called vibrations.pdf in our Google Drive. So once again, let's click on the run. And so this time it has run, and I'm sure that it has been created, that has been saved in our Google Drive location. There are many more things that you can do with the savefig function from matplotlib. And once again, you can go and check out the various options for syntax possibilities, which are possible with the savefig function. Our last command will be to enter the plot show. Let's run it now. Once again, you can see that the graph has been created and it's been shown on the screen. It may be that we want to plot a fourth vibration. So let's see, we can do plt.plot x y4, label equals three point zero. Making sure to get our syntax correct. And then run. Okay, we've got a problem. What could be the problem? So let's read the output of the message. Traceback, line 12, PLT Y4, what could that be? And it gives us an error message which says name Y4 is not yet defined. So let's look back and go, all right, we haven't defined the function. So let's go Y4 equals just going to cut and paste. Click run again. This time we've got our graph with our fourth vibration and everything is updated and it looks well without any errors this time. Okay, one of the things that we talk about a lot in the context of this exercise is the fact that Colab can be used for collaborative programming. And I want to talk a little bit about that. First thing that I would like to say is that if you are collaborating on a program, you're probably going to want to include comments, and we have included a number of comments about what a number of functions do and perhaps how they are defined. It's also a good idea to have a header section which gives some indication of what the piece of code is trying to achieve. It should identify the author or authors. It should have a date, and it should have a version, and it should have a change log to identify the things that were implemented in the course of the lifetime of that piece of code or the development of that piece of code. So in this case, the name of the example is a simple 2D plots. It was written by Carsten Fleischer. It was amended by Ray Murphy. The date was July 2021, and we're given it a version 1.1. That version can change every time it changes, perhaps. So we also have a change log. So the Python code was written for the function as we see it there. So some of the things that I've done on the screen in front of you in a short while are to add the header, which you're looking at now, add a fourth function, which you observed, add a title to the plot using the command below, and identify that the function that we're implementing is described as such. So once again, we can click on Run and see that the graph is created correctly. One of the things that you can do is you can add another code cell, but I don't have any more code to add, so I'm just going to delete that cell. It's the second one that I want to delete. So our project at the moment is PS154 2D graph with that title. Maybe I'll call that PS154. Consistent. Run it again. Let's see that it's all correct. We can change the name of this. Let's say Murphy's 2D graph. Let's run it and see what happens. And that will be saved in the vibrations.pdf file as well. So let's say we've completed our project and we want to share it. There are a number of options. You can simply download it. And there are two Python file formats available. It could be that the piece of code that you've written might be for use in a piece of hardware. It could be that you want to use it on another platform. In any case, you may just want to record it for use at a further time. So you can download that piece of code and save it to your own computer. As it is now, it is available to you online, and you can save a copy in your Google Drive. You can save a copy in GitHub. GitHub is a collaborative source of code. You can contribute to that, or you can use code that other people have created. On this occasion, I'm going to save a copy in Google Drive. So I'm going to go File, Save a Copy in Drive. And so it has now created a copy. Let's call it copy of PS154 2D graph. It may be that you want to change that. It may also be that you want to collaborate with other individuals, fellow students, or other people with a Google account, in which case you can click on Share and seek to give those people access to it so that the program can be modified and developed. Okay, so in this piece, I've shown you how to create a simple Python program using Colab, and I've shown you how to save that piece of code and perhaps share it so that you can collaborate with other people in developing that piece of code. Okay, so let's just summarize what we what we did. We created a blank notebook using Colab, we gave it a name, we added title and text, we added code, we ran the code, we debugged the code when we discovered that it had a problem, or there was a problem with something that we entered. We saved the output of the program as a PDF, and we shared the code. And we annotated the code before we did that. Okay, so this was a simple exercise in developing a piece of code incrementally, entering some lines and then more, and debugging as we went along. And so this is a simple example of creating a piece of Python code and saving a plot. So good luck developing your own pieces of Python code using Colab.